Hello. In this video, I'm going to show you how to create your own data type in C++ using classes. First, let's have a definition. Abstract data type, or ADT for short. What is an abstract data type? It is a data type that is created by the programmer. It is the programmer that will define what data is going to be stored within this data type. And it is the programmer that is going to define what operations can be performed on this data type. We'll use classes to define an ADT. So let me show you the syntax for defining a class, and thereby an ADT, which is a data type created by the programmer. Okay, so the syntax looks like this. We have the keyword class, and then we're going to have the name of the class after that, and the name of the class is going to be any valid identifier within the C++ language. We have an opening curly brace, closing curly brace, followed by a semicolon. And inside the body here, we're going to have some attributes. And these attributes are going to determine what types of data are going to be stored within our new data type. Also, what types of operations can be performed on this data type. Okay, so the attributes are anything that belong to a class. They could be variables or they could be methods. Attributes are going to describe the abstract data type, the ADT, that we are creating. Right, so let's create a brand new ADT, a new data type called rectangle. Okay, so let's do that. And our rectangle is going to need some attributes to describe it, such as the length and the width. So let's put those in here. Okay, now our rectangle will be able to have a length and a width that can be fractions of a unit, right? So we could have a length that is, say, 3.2. So we want to have the data types for these attributes to be double. Okay, so we're going to store length and width. Okay. Okay, so we've defined a rectangle in the abstract as some object that has a length and a width. Now we need to define some operations we can perform on a rectangle. These operations are known as behaviors, or methods, or member functions. Okay. We want to be able to set the length and width of a rectangle object as well as get these values from the object. So let's add prototypes to our rectangle. Okay. We'll do that right now. So let's have set length, okay, and it's going to accept the double. Let's have set width, and it's going to accept the double. And let's have double get length and double get width. Okay. So in addition to these three prototypes we've defined, we've added three new keywords: private, public, and const. Private and public are known as access specifiers. Everything listed after private is internal to the class. Now, consider a statement that looks like this: int x set to 5. Okay? 5 has been assigned to x, but you don't control how 5 is internally represented. And you don't need to know how it's stored. You just used a public operation, in this case, the assignment operator equals, to store 5 inside of x. We'll store length and width similarly. Everything after public is available to client code, or code outside the rectangle. In the previous example, you could consider equals, the assignment operator, as being a public operation for x. All public attributes are said to be part of a class's public interface. The keyword const indicates the associated behavior cannot change the rectangle in any way. Methods with const are said to be accessor methods, and methods without const are said to be mutator methods. Okay, so let's define the methods, and then I'll give you examples of us using these methods on the rectangle. Okay, so the definitions will be outside of the class definition here that contains the attributes. Okay, so let's do set length first. All right, this is like defining any other function, but we specify which class the set length method belongs to. In this case, rectangle. Okay, on line 14 before the double colons, that's what we're talking about. Length set to L on line 16 assigns the value inside parameter L to the class attribute length. Okay, now let's finish the other three methods. Void rectangle set width. It's going to be very similar to set length. Okay, set the W. And then let's do get length and get width, double rectangle, our accessor methods. Okay, and then we're going to do the same thing with width. And return width. Okay, so let's use our new abstract data type. We have an abstract data type called rectangle, which defines a new data type. I wrote it, I'm the programmer. And now we've just added this new data type to the language. So in our program, we can do something like this. Okay, so that's going to create an object of type rectangle. Now, notice no values have been assigned to it yet, just like any other uninitialized variable. Okay, so let's assign dimensions to our rectangle that we've named R. Okay, we'll do this by invoking the set width and set length methods. Okay, 12.5 and R dot set length, let's say 2.0. Okay, so these statements on line 41 and 42 are going to assign 12.5, right, it's going to be passed by copy, to the private width variable here. Okay, and 2.0 is going to be assigned to length. Okay, length and width are both attributes of rectangle R. So we've set 12.5 and 2.0 to the length and width that belong to this rectangle we call R. Okay, so now let's get those dimensions. Okay, now that we've assigned those two values to this new data type we created, let's retrieve them. Okay, so cout R's width is r.getWidth. Okay, and length is r.getLength. Okay. Oops. Let's put an inline here. Okay, then we'll compile this and test it out. Let me throw my includes in here for cout and inline. Oops, include IO stream. Alright, so let's compile this and run it and test it. Okay, so there's the length and the width. Right? I've assigned it 12.5 and 2.0 to this rectangle R using its methods that are part of its public interface, and I've retrieved those values by using the accessor methods. Okay. Now, what if I want to get the area of this rectangle? Well, I could do something like this, right, where I could say r.getWidth times r.getLength. And if I compile and run this, I get its area 25. Okay, that works. But why don't we define a new operation for rectangles? Let's go in here and just add another method. Okay, we'll call it get area. So we'll add the prototype to our class definition, and then we'll define that method. So double rectangle get area const. Okay, and what we want to do is we want to return the length times the width of that rectangle, right? Of an instance of this rectangle, right? So length and width will be stored inside these private attributes, and then we'll have this public get area method, which will return the product of those two things. So now, if we have a statement that looks like this, if we want to find the area for R, all we have to do is say cout area equals R dot get area. Okay, so let's compile and run that. Okay, so this first R's dot get area was line 55, but the second R's area is from line 57. Right, so now instead of having to invoke two methods, I can just invoke one. You can add as many methods, to find as many operations on your new data type as you like. That makes sense. Okay, now in line 45 we went and initialized a primitive variable, an integer variable x, with 5. Okay, now the question is, can we initialize ADTs? Well, the answer is yes, but we're going to use a special method in this video to do it, and that method is known as a constructor. Constructors are called automatically when an object is instantiated. So when we do rectangle R or rectangle T or something like that, okay, that constructor is going to be instantiated, or excuse me, invoked. Now there's a whole bunch of different rules for using constructors and how they're going to work. But I'm not going to go into all of those with this video. I'm just going to show you enough to get you started. Okay, we'll cover in class more on constructors. Just want to let you know what they are here. Okay, so constructors have no return type and have the same name as the class. So let me clear this stuff out right here. Okay, and let me add a constructor to my rectangle. Okay. So they have no return type, so I'm not going to specify in its prototype any return type. I'm just going to use the name of the class as the name of this method. And in this case, I want to be able to initialize a rectangle object with any values that I want. So I'm just going to specify a couple of parameters here. And those parameters are going to be used to initialize length and width here. Okay. So now let's add a definition for the constructor. No return type again. Okay, we're specifying this first rectangle here. That's specifying that it belongs to class rectangle, this method, and then the second rectangle is the name of the constructor. Okay, so let's have two parameters. We'll name one L for length, and we'll name one for W for width. Okay. All right. So inside of our constructor, we'll have a couple statements that just do this. Length set to L, width set to W. Okay, so this constructor, when it's invoked, is going to initialize the private attributes length and width. So how do we use it? Okay, well, when we provide a constructor, our definition of a rectangle variable and instantiation of the object, the syntax is going to be a little bit different. So let's do this. Rectangle R, but now we're going to add parentheses after here. We're going to add some arguments. So what can those arguments be? How about 2.5 and 3.0? Okay. So when we do this, what happens is that 2.5 and 3.0, as soon as this statement executes, then this constructor method automatically is invoked. You don't do anything, it just runs. Okay. And so what will happen is that 2.5 will be assigned through parameter L, passed by copy, to length. Okay, and 3.0 will be assigned through pass by copy to, oops, width, typo. Okay, So it's going to work just like any other method. It's just automatically invoked when you have a statement like this. So let's call the getArea method and demonstrate that this worked. So here's an example of it being used. Okay, so let's do cout r.getArea. Okay, and I want to put a little note here or whatever. R's area equals. Okay, so let's compile that and run it. Okay. All right, so there we see that R's area is 7.5. So I initialized rectangle R with 2.5 for the length and then 3.0 for the width. Okay. All right. So what if, let me ask you another question. What if I wanted to compare the area of two triangles? All right, let me create a second triangle. Okay, we'll call this one rectangle T. Okay, and we will give it its own values. How about 2.0 and 1.5? Okay, so we're going to see that what's going to happen here is we're going to create two instances of rectangles. So we're going to have two rectangle objects. Okay, one will refer to by the identifier R and one by T. And we're going to see that they both have their own separate value, just like if I had int x and int y, right? If I did something like this, if I said int x equals 5 and y equals 10, right? I've got two integer variables. X has 5, y has 10. Well, in the case with the two rectangles up here, you know, I've got two objects. R has 2.5 and 3.0 inside of it. T has 2.0 and 1.5 inside of it, right? So those are two different variables essentially, right? So if I do cout T's area equals, right, I'm going to get a different area. Okay, so let's compile that and run it. Okay, so R's area is 7.5, T's area is 3, right, which is what it should be. Okay, two different rectangles, two different sets of lengths and widths, two different areas. Okay, so I could compare the areas by doing something like this. If r.getArea is greater than t.getArea, right? Then cout r's area is bigger, right? Something like that. Okay, let's compile it and run it, see what happens. See if I make mistakes. Okay, r's area is bigger, and that's true, right? Because 7.5 is greater than 3. So that works just fine. Okay, but why not define a new operation, right? Why don't we do something like this? Take a look at this prototype. Okay, bool is greater than, right? Oh, that's the rectangle reference parameter. Okay, why don't we do something like that? Okay, if we define this, and let me write a method definition for it, and then we'll talk about it a little bit more detail. Okay, don't forget this is going to be part of class rectangle. Okay, what if I do something like this? Return getArea. Okay, so that's calling the getArea method of the current object, right? This is calling my getArea method. And I'm going to compare my area against my arguments area. So RHS.getArea, something like that. Okay, so this is going to return true if my area is greater than my arguments area, right? So something like this. If it turns, we can change line 64 to something like this. If R dot is greater than T, then we'll say, I'll just copy and paste this. Then we'll say cout R's area is bigger. Okay, so what we're doing now is we're passing another rectangle as an argument to another rectangle, right? So is greater than is going to accept T, this instance, as its argument, and then once we've done that, we're going to invoke this pass by reference. We're going to invoke its getArea method, and compare its area to r's area, right? So r's get area method versus t's get area method. And then if r is bigger, if its area is bigger, then this is going to return true. False otherwise. Okay, so let's compile and test that. Okay, and we see r's area is bigger. So now I've demonstrated another way that we can compare. Okay, now, why is this passed by reference? Why is this const? Well, remember, with passed by reference, you're able to change the source argument, right? So with passed by reference, I could change the contents of T, right? I don't want that to happen, right? The only thing this is greater than method is doing is a comparison. It's retrieving some information. It's not changing the object in any way. In other words, it's an accessor. So I want to make sure that I don't accidentally change, my argument's values. So we're going to make that const, right? Why is it reference in the first place? To make this example easier, okay, we're going to use pass by reference. If we didn't, we'd be using pass by copy, which is a whole nother topic, which I'm not going to cover in this video. Okay, we'll cover that in chapter 14. Okay, so there's an example of us using a method to compare the contents of two objects. Okay. All right. So a constructor is a special method that's called when an object is created. Question: is there a special method that's called when an object is destroyed? The answer is yes, and it's called a destructor. Okay, a destructor has no return type, it has no parameters, and it also has the same name as the class but prepended with the tilde character. Okay, usually the destructor is going to be used to deallocate dynamically allocated memory, right? So what could the destructor look like, or what the prototype for a destructor look like? Okay, now by definition it's a mutator, because it's going to, if we're going to deallocate dynamically allocated memory, for example, that would be changing the object in some way, right? So it can't be const, okay, but it's going to have the same name as the class with this tilde character in front of it. Okay, no parameters. Okay, and so then we would define this thing just like we would any other method, right? It just doesn't have return type, doesn't have parameters, whatever. Okay, so there is a definition for the destructor. Now whatever code we put in here, okay, this code is executed right before the object dies. Right? What do I mean by object dies? Your program terminates, the section of code, maybe the function that your rectangle is defined in goes out of scope, something like that. Anything that would cause this rectangle to be destroyed. Okay? All right. Okay, so speaking of dynamically allocated memory, and I'll finish up with this, I think. Okay. Our rectangle can be used with dynamically allocated memory. Okay. So let me show you really quick what I mean. Okay. Now, an abstract data type is a data type. So generally speaking, anything you can do with a primitive data type like an integer, double, float, whatever, you can do with abstract data types. You might just have to do a little extra programming to support everything that you can do, but generally you can do it. Okay. So in this case, we can use dynamic memory allocation to create a rectangle. Okay. So how am I going to do that? Okay. Remember, with dynamic memory allocation, we have a pointer. We got the new operator, etc. Okay. So let me define a pointer really quick. Okay. And now we'll assign to it a newly allocated rectangle, rectangle that we're going to dynamically allocate. Okay. So something like this would dynamically allocate a rectangle, okay, that doesn't have a constructor that we defined. We defined a constructor. It has no default constructor. But for us, we have defined a constructor. So what we're going to do is we're going to add that parentheses syntax, right? So I want to dynamically allocate a brand new rectangle, and I want it to have the dimensions 1.5 and 3.0. Okay, so New is going to ask the operating system, hey, create this new abstract data type, create an object of type rectangle, initialize it with the values 1.5 and 3.0, and store the memory address of that rectangle inside this pointer rptr. Okay. All right. Now, don't forget, before you leave, whenever you do dynamic memory allocation, you have to destroy the dynamically allocated memory. So we use delete on the pointer just like we would any other primitive data type. Okay, so now what if I want to find out what the area is? What if I want to use one of the methods? Okay, well, how do you get to the memory location for a primitive that you've dynamically allocated? You got to dereference it, right? So I'd have to do something like this. Okay, rptr dot get area. Okay, so let me do that as a cout so we can see it. Okay, cout r pointers area equals. Okay, oops, something like that. Okay, let's compile it, run it. What do we get? Okay, we get rptr's area, which is 4.5. So what we've done here is we dereferenced the memory address. That took us to the location where the rectangle object is that we dynamically allocated, and then we invoked its get area method. Okay, why do we have to have the parentheses here? Order of operations. Dot operator has a higher order or a higher precedence than the indirection operator, right? So we have to do that. Now, if you don't want to remember the order of operations, you don't want to remember that you have to use the indirection operator, there is an alternate syntax that you can use. Okay. All right, and that syntax is this. Okay, cout r pointers length. Let's look at its length this time. Okay, we just do something like this. We use this arrow. It's a dash and the greater than angle brackets, right? Get area. Not get area. I wanted to get the length, right? Okay. So this is just a line 79, just a shortcut notation, something that's a little bit easier to remember than the dereferencing thing we got to do in line 78 that we did in line 78. Okay, so let's compile, let's run it, and we can see that it works, right? There's our PTR's length. Okay. All right, so that, I think, is everything that I wanted to talk about in this video. There's a hell of a lot more to classes than what I've shown you. I just wanted to get your feet wet, maybe get the gears turning, just give you an example that you could look at whenever you wanted to. We're going to go into a heck of a lot more depth covering abstract data types and classes. There's a heck of a lot more features. This is just the very basics to get you started. So in summary, we talked about what an abstract data type is. I introduced you to the syntax of creating a class. We talked about what attributes are. Talked to you about public and private access specifiers. Talked about methods, and we talked about constructor. We talked about destructors. I showed you how to instantiate objects based on the classes that you wrote, which defined the abstract data type that you created. And then I also showed you how to use dynamic memory allocation with the new data types that you created, in this case for our class rectangle. And I also showed you how to create a destructor and told you about what its primary use is or how you use it. And I showed you some shortcut notation for using dynamically allocated objects. Okay, thank you for watching this video, and as always, if you have questions, feel free to shoot me an email or stop by my office hours. Okay, great. Thanks for watching. We'll see you next time.